Hello! In this tutorial, you will be generating board game review predictions by using machine learning. This is going to be an awesome project where we import a data set of over 80,000 games and then use that information to train both a linear regression model and a random force regressor to make predictions based off board game informations. This is going to be the final product of this project. So we have 80,000 games with information like this: minimum players, maximum players, playing time, etc. And then we use a linear regression model, which is linear, and then a nonlinear random force regressor, both to make predictions that end up being pretty good. So for this particular game that was published in 2012 and has had over 19,000 users rate, we were able to fairly accurately predict the actual average review based off only the information shown above. So our random forest regressor is slightly better than the linear regression prediction model, but that's to be expected with a data set such as this and a linear versus nonlinear regressor. So I hope you tune in. I will be walking you through all of the steps needed to generate this output, how you train the models, how you load and pre-process the data set appropriately. So I hope that you will learn a lot, and I look forward to showing you how it works. Thank you very much. Hello everybody, and welcome to this tutorial video where we are going to be building a board game review predictor using a couple different regression models. We're going to use a linear regressor, and we're also going to use a random forest regressor and compare and contrast the results that we achieve in both of them. So this is going to be an excellent project. We're going to use a GitHub repository, so I'll show you how to install and use GitHub as well. And then once again, just like in our other project videos, we are going to be using the Jupyter Notebook to actually develop our application, as well as Conda to install and manage our packages. So let's go ahead and dive right in. So for this project, we're going to need data, as all machine learning projects do. And that data today is going to come from an individual on GitHub who built a scraper that pulled a bunch of board game reviews and board game informations from Board Game Geek, I believe was the website. So this is open source data and it's available on GitHub, so I'm going to show you how to get there. And this is GitHub here. And actually the repository that we are going to be using was developed by Sean Beck, and so he's got a lot of different stuff on here. Once again, all open sourced. The Board Game Geek is where we're going to want to go, and he has this games.csv which has all the information we need. It has, I think, around 81,000 different board games that are in this file and have information for and reviews. So it is an incredible source of information that will be available to us. And so it's usually important to check licensing. This is GitHub, so if it's most of it's open source, but here we see again that this has an MIT license, which means that we can use it and modify it in any way that we would want without liability or warranty. So this is freely available to us. No worries about that there. So let's show you how you get this going. I'm going to start up my Anaconda, so I'm going to go to the command prompt. I'm actually going to run this as an administrator just so I can modify some of my Conda information. So cd, I'm going to go over to my tutorial folder. So there's that. Alright, and so now there's a couple different ways to get information from GitHub. If you go back here, you can, GitHub's divided into repositories. You could download or clone this entire repository straight from online using this button here, and it provides the link, and you can download a zip file just like that. However, GitHub comes up a lot, and oftentimes you need to pull information from different repositories from the command line. So I'm actually going to show you how to install Git. I'm on Windows, so that's what I will be using, but there are installation instructions here for both Linux, Mac, and of course Windows, or you could install from source. So these are all good methods. I'll be doing the Windows method, and we'll show you how to get that set up. This installation is going to allow us to download these repositories straight from the command line. So let's do that. If you followed along with the other projects, like I'm sure you did, then you have Conda already installed. Remember, Anaconda is a package manager, and so you can install Git straight from Conda, and actually that's what I'm going to be doing. They do suggest using a Windows installer here. However, since we've been using Conda, we're going to go ahead and do that. So Conda install Anaconda Git, and this is going to do the installation. I already have this installed, so I'm not going to go ahead and click enter. But if you need to get Git, this would be a good time to pause the video, run enter, or run this command here, and make sure everything's set up and installed correctly. Alright, once we have that, we can go ahead and clone the repository. So cloning repositories, once you have Git installed, is very, very easy. All you type is git clone, and clone is the same as like a download. It's a copy and download. And then we're going to type in our URL here. Actually, we can go straight here, and we can just Control A and Control C to copy this if we want. So here is the URL, and this is the Scrapers repository from Sean Beck, username the Weatherman. So once we have this, and whatever folder you are currently in is where it's going to download it. So we'll go ahead and click enter. So it's cloning, and here we go, and it got all those. So let's go ahead and open up our Windows Explorer, and we'll see if this did indeed download. So yep, we have the folder here. We actually don't need this entire repository, so what I'm going to go do now, and you see that all the files listed up on the GitHub page are here. What I'm going to do now is I'm going to go into that Board Game Geek folder, and I'm going to get that games.csv file. I'm going to copy it. I'm going to come all the way back out to my tutorial folder and just paste this here. That's all we actually need. So I can go ahead and just delete this now, and we'll get rid of that. Alright, so we have our data set. And now let's dive into opening it up and using it in Jupyter Notebooks with Python. So we'll go back to our command line here, and we'll just type Jupyter Notebooks. And Jupyter's in your path. This will open up, or Jupyter Notebook, excuse me. This will open up a notebook in your web browser. So this can sometimes take a second or two, but here we go, and it's starting that up. Alright, and so whatever folder that you were in when you type Jupyter Notebook, once again, is where it opens up your project. So you can see we have our games.csv file right here since we're in the tutorial folder. That's perfect, that's what we need. I'm going to start a new notebook here, just do Python default. And let's give this a name. We'll call it Board Game Review Prediction. Perfect. And now we will know what it is. Alright, so we're going to have to import a couple packages. And remember, if one of these throws an error, it's as simple as going back and typing conda install whatever package you needed. But for now, let's just import them and make sure that we're all on the same page. I'm going to do an import sys so we can see which version of Python I'm using. Import pandas, import matplotlib, import seaborn is a new one that we're going to need, and then import sklearn. So I want to do print functions here so we can see which versions we are using. Oh, no capital needed. So we'll do this for all of them. It's important that we're using the same versions sometimes because you'll get different results. So it's always a good idea to check. I'm using Python 2.7. That's going to be the most important one. But all these others are good to check as well. Alright, So Shift Enter to run this cell. And it's thinking, it's trying to import all of these. I should have all of them installed already. You may need to go back and install Seaborn. These other ones we should have used in previous projects. So those should already be available and accessible. It is thinking. And there we go. So Python 2.7, this is the pandas, matplotlib, Seaborn, and sklearn. All right, but we actually need to go back and import some specific packages. So let's do import matplotlib.pyplot as plt, and we're going to import Seaborn as SNS. And then we're actually going to import the models, well, the sklearn models that we need. We might actually, well, we can do the train test split from this one. We'll wait on doing the random forest and the linear regressor until later. So we're going to need the model selection, import train test split. All right, and we're going to go ahead and click Shift Enter on this once again. So there we go. We see the 2. It's successfully run. No errors. All right. And now let's work on loading in our data set using pandas. So it's really easy. We're going to call this our data set games. This is going to be a pandas data frame. And it's going to just do pandas.read CSV, very appropriately named. And then just the name of the file here. And we should be good to go there. So let me add some comments for readability. Comments are always good. Load the data. All right. And let's actually just click Shift Enter there. We'll see if we can get that. We should. Yes, it does it very quickly. All right. So now let's explore this data set a little bit to see what we have in this games.csv vault in this file. So let's print the names of the columns in games. And so to do that, we'll just do print games.columns. And actually, let's do a print games.shape as well so we know how much is there. All right, here we go. So we have, oh wow, we have 81,000 games, 312, 20 different columns. We have ID, the type, name, year published, minimum players, max players, playing time, etc., etc. So the one that we're really interested in is the average rating here. This is what we're going to be trying to predict based off some of these other characteristics of the game. Like average weight here, weight is a function of the complexity of the game. So the higher the weight, the more complex the game is. This one's actually going to be important for our final predictions. All right, so let's explore this a little bit. Let's make a histogram of all the ratings in the average rating column. Average rating. All right, to do that, we'll use PLT, and we can just use the plt.hist. This will generate a histogram. And so we want games. But we don't want all the columns, we only want the average rating here. So just the average rating column. And then after that, we need to show the plot. So PLT, you need to do or the pyplot, you need a plt.show. So Shift Enter. All right, here we go. And this is kind of unexpected. So we see here, we have almost 24,000, 25,000 games with an average rating of 0. So that's not really promising. But let's explore what this means a little bit more, because right now we have a lot of 0, and then we have a skew to the right where we have an average prediction of 6 just about. So let's do a print the first row of all the games with 0 scores. So we can see what's going on with these guys. And so we're going to use the .ILOC method, which for data frames allows us to index by position. So we'll do a print games, and we'll have the games average rating again, where this is equal to 0. Those are the ones we're interested in, and we want to do .ILOC. This is indexing by position. We'll just take the first one of those. All right, and to compare and contrast this, let's do a print the first row of games with scores greater than 0 as well, so we can see what's going on with those and if there's differences. So I'm going to just go up here. I'm going to highlight this, Control C to copy, and then Control V to paste. I'm going to change this right here. We don't want equals to, we want greater than. All right, so let's explore this. Shift Enter. So here's our first one where our review equals 0. So we have an ID, type, name, and then just no information. So we have one wisher. I'm not entirely sure what that means. Maybe somebody wants this game, but it looks like it was never published. 0 users rated, average rating 0. So this game doesn't exist, and that's why we're getting this information. However, this one, Twilight Struggle, published in 2005, and has all this other information. So average rating 8.3, pretty good, because 20,000 people actually rated it. So we want games where people have actually reviewed these, so that we don't have all of these zeros in our data. And once again, when we're doing machine learning, this is why it's so important to explore the data before starting, because sometimes you have information like this that is going to really impact your results in a negative way. So let's take care of that right now. What we're going to do is we're going to remove any rows without user reviews. So this is going to be pretty easy. So we want our data frame games again, and we'll just do games where the users rated is going to be greater than 0. So as long as somebody's reviewed this game, somebody's played it and reviewed it, we're going to assume it's okay. And then we want to remove any rows with missing values as well, because that is also going to impact our results. And this actually is going to be dropping the first axis, so we'll just do axis 0 here. All right, and now let's make another histogram. And we'll do the average ratings again. So once again, this is plt.hist. So games, average rating. Awesome. And we need the plt.show as well. Shift Enter. We'll see if this comes up. And it does. Here we go. Let's see that. Looks much better now. We don't have that 0. And everything looks more appropriate than before. You see we actually lost some here. We had some missing data, so this shape as well changed slightly. All right, so let's move on. What we want to do is actually, well, first, this I believe was dropping the ID column. Let me do a game. We'll do a print games columns, and we'll run this again. Okay, so we have all the same information in there. We might want to go back and drop this ID column, but we'll see how it impacts our final results. The ID column doesn't really tell you any useful information about the game since it is assigned arbitrarily. However, you might get some biases, and it might result in actually overfitting if you include IDs in your machine learning training data. But for now, let's develop a correlation matrix. So what this is going to do is going to tell us if there are some strong correlations between some of these parameters in our data set. So we're going to use Seaborn for this, and this is a really cool way to do a correlation matrix. We've done it slightly different in the past, but this is a new way, so we'll see how this works right here. So we want a correlation mat, and we're going to develop this with simply the games.core, which is part of the Pandas data frame. So this right here is the Pandas data frame, and this is one of the functions that they provide. So we need a figure, so we'll do a plt.figure, and I'm gonna assign a figure size to this, simply so it looks nice. So that's that. And then here we have our Seaborn. We're gonna have the SNS, and we're gonna develop a heat map, and that's gonna be based off our core mat or our correlation matrix. And we have some parameters here just to make it look nicer. Square equals true, so there's those. Alright, and let's try this one more time with a plt.show. See if this works. Alright, shift enter. So this will take a little sec. Okay, we have an error. Let's see what our error is. We spelled a word wrong. Alright, there we go. And here it is. So this is really awesome. And it's a heat map, so it's showing the correlations between our different parameters here, with 0.8 being the highest, and that being a white, and all the way down here in the black and about the 0, that is no correlation. So I see some pretty obvious correlations right now. No surprise, playing time is highly correlated with min playing time and max playing time. So that doesn't really tell us much useful information. But down here, we see some other things as well. The total weights is fairly highly, or the average weight. And remember, our average rating is the one that's important. So you see the ID is highly correlated with the average rating. And then, as well, the average weight is fairly highly correlated. So some of these, like the min age is correlated with the rating as well as the base average rating. We're probably going to want to remove that because it's based off the average rating. So we're going to remove some of these because they don't actually tell us useful information. We don't want to have the type or the name or the ID, because this is all stuff that isn't actually characteristics of the game, but since they are highly correlated, are going to impact our results of our machine learning algorithm. Alright, so let us do that now. So what we're going to do, this is part of the dataset preprocessing, very important to machine learning. We're going to get all the columns from the data frame. And to do that, we need columns equals games.columns.toList is a very convenient function to generate a list, a Python list. And then what we want to do is we're going to filter the columns to remove data we do not want. So this is a very important step here. And so we'll have columns equals, and we're going to do a for loop in here. So C for C in columns, if C not in, and then here are the ones we're going to be excluding. So we don't want the base average rating because that's based off the average rating, so it doesn't really tell us useful information. We're also going to want to remove the average rating because we don't want to be trying to predict data that's in our training set. And we're going to remove the type, and we're going to remove the name, and then lastly we're going to remove the ID. So those are all data that we don't want. But we also want to store the variable we'll be predicting on. So to do that, we say target, and target being our target variable is going to be average rating. Alright, so let us just run a shift enter on this. So this will filter out the Bayes average rating, the average rating, type, name, and ID. And now we're going to split the data sets and generate training and test data sets. So to do that, we already imported this, but it's from the sklearn. Here we go. Learn.cross validation. So you don't need to type this again. Just for readability, though, it'll be nice to have this down here so we know where our functions are coming from. So we are also gonna, right here, we're gonna generate the training set. And we're also gonna set a random seed so that we can replicate these results. So we'll do trains games.sample. So fraction, we want about 80% of the data. So that's 0.8. 20% of the data for a testing data set is usually pretty standard. You want about 20%. So random state, we're just going to set to 1. Not so random. But this will allow us to reproduce our data and allow you guys to get the same results that I'm getting. Alright, so we want to select anything not in the training set. And we're going to put it in the test set. So to do that, we want test equal games. And so we'll have .loc. So this is going to be label-based indexing. And we're going to do the games.index.isinTrain.index. And instead of a parentheses here, I need a... Oh, nope, that's right. Train is in... Yep, there we go. So let me also print the shapes of both of these. So we'll do a train.shape so we can see if our data was divided up appropriately. So we'll do a test.shape as well. So shift enter here. And here we go. So this actually got removed in favor of model selection. So let's see if I can remove this and it will be... There we go. Now it is not yelling at me. So I have 45,000 games in our training data and 11,000 in the testing data. So pretty big data sets here. And that is what we want to see. Alright, so I'm going to actually stop this video here. This is just setting up the data set. In the next one, it'll be a little bit shorter. We are going to dive into using our linear regression model as well as our random forest model and compare and contrast the results. So good job getting the data set imported from GitHub and pre-processed in a way that we can now use it for machine learning. So talk to you soon. Thanks. Welcome back to this tutorial. I'm building a board game review predictor with regression models. So just to summarize where we are at right now, we have developed a training and testing data set with 45,000 games in our training data set and 11,000 in our testing data set. And that was from data that we imported from GitHub and then pre-processed in here. So we downloaded our games.csv from Git and we pre-processed it to remove incorrect or inaccurate data, such as games with an average rating of 0 and 0 users, as well as games that were missing information. So all of our games have information. And so we have 20 columns. We've seen some correlations between variables here, but not a lot to go on. And so we're going to dive in now to using a linear regression model and a random forest model. So let's go ahead and do that. So the first thing we need to do, as always, is import our models. So we're going to do that. Import linear regression model. And we'll do the linear regression model first. Linear model import linear regression. So there's that. And we also need some some errors. So this is linear regression. So one of the most common sources of error, well, not sources of error, but metrics for error is the mean squared error, which is just the average distance between each prediction and each label. So we're going to import that. This is what we'll be using to determine how accurate our model is. Okay, so the next step is to initialize the model class. And to do that, I'm just going to do LR for linear regression, and that is just equal to linear regressor, or regression, which is this entire class that we imported from sklearn. So click enter there. And now it's really simple. All we need to do is fit our data, or fit the model to the training data. So this is optimizing the parameters of our regressor so that we can make more accurate predictions. So we'll do LR because that's our model.fit, and we're going to use our training data set here and the train target. So we have the columns and we have the target. There we go. Make sure our brackets are correct. And so let's go ahead and click Shift Enter here to see if we've got everything correct so far. So yes, we do. It looks like it fit the model. So now we can move on to making predictions and classifying those predictions using our mean squared error. So let's generate the predictions for our testing set now. So remember, the accuracy on the training data is not important because we want to make predictions or learn new information from these models. So we want it to generalize well to new information, and that is why we test each model on a testing data set or a validation data set. So predictions equal LR because that's our model dot predict, and we'll do test, and then we are going to need only the columns here. So that'll do our predictions. And then what we want to do is we want to actually compute error between our test predictions and actual values, because that's what's important. That's what we want to know. So for that, we're just going to do the mean squared error, and we'll compare our predictions to our test, which is the target value of each of the games in our test data set. So if you remember, we split up the training and testing so that the target would be average rating, and then the columns would be everything else. Okay, so let's see how this did. We'll go ahead and click Shift Enter here. Oh, so we got a mean squared error of just over 2. Not bad, but not great. Not surprising, this data is fairly complex, so there's not a linear model that's going to fit it perfectly. Perfect fit would be a 0 here. So now let's actually move on to a nonlinear model and see how much better it does, or if it does do better at all than our linear regressor. You know, up here in our correlation matrix, with average rating, we didn't see anything that would indicate a strong linear relationship, so it's not that surprising that our linear regressor or our linear model isn't going to be a perfect fit for our data. So it's off by 2 on average for each game review. So let's move on, and we'll do import the Random Forest model. And so that's from sklearn again. And we'll import the Random Forest Regressor. So this is a decision tree based model, and it's going to be able to achieve nonlinearity. So we want to initialize the model, and we're going to actually throw in some parameters here as well. So I'm going to do RFR, so our Random Forest Regressor is going to be equal to the Random Forest regressor. And we want to actually up the number of estimators here. So we'll do 100. And min samples. And then random state again so that this is reproducible. And this should be leaf actually. Okay, let's try to fit that to our data and see if it's able to achieve that. So we'll do our RFR.fit, and we'll do the train, columns, and once again, we need our train and target. Okay, so this is our training data set, and we're fitting the training or the model to this data set. So that means we're optimizing the parameters. And here we go. Capitalization error here. Should have seen it coming. Alright, much better. It looks like we're able to go now. So it will think for a sec. Thinking. And so it takes a slightly longer time to fit than our linear model because it's basically a combination of multiple linear models in a decision tree. So I'm not going to go into the details of a random forest regressor. However, it is often used for both classification and regression tasks. If you have data that needs a nonlinear model, it's a good choice a lot of the times. Whereas the linear regression model is a lot quicker and a lot faster and a lot simpler. It's not always the best. Okay, here we go. So these are all the parameters of our model. Let's move on to making some predictions. So we'll have predictions. These are going to be equal to our RFR.predict, and we'll have the test columns. So we want to just predict on the testing columns. And then, so let's add some comments here. And then we'll move on to compute the error between our test predictions and actual values. Alright, so let's see if we beat our linear regressor. We'll do a mean squared error again. Predictions, test, target. Alright, so we'll go ahead and click Shift Enter here. And we did by almost half a point in our average reviews. So our mean squared error here is 1.445, and that is better by a fairly significant amount than our linear regression model up above. So maybe we need something more accurate than this, maybe we don't, but it is interesting to see that a nonlinear model is able to achieve better results than the linear regressor. To explore a little bit more about these predictions and what they look like, let's predict the rating for an individual case instead of our entire testing data set. So what I want to do is I want to print out one specific value, and I'm going to use the .iloc notation once more so we can do positional based indexing for our data frame, since this is a pandas data frame still. So let me print this out. I'll do Shift Enter, and so here you see the first game, and we have a bunch of these, so you could do whichever one you would like. I'm just going to do the first one, or you can do multiple if you so desire. So here we go. Here's our information. The year nicely rounded to 4 decimal points. We have min players, max players, playing time, etc. All the same information that we had before. So now we can predict our rating. So what we'll do is we'll do an RFR, since that was our better one. Well, actually, we'll do both. So let's start with a linear regression model. We'll do predict test columns .iloc, and we want the first one here. And what we're actually going to have to do, since this is an individual value instead of an entire data set, we're going to have to do a values.reshape. So this is in a format that the model can understand. So we'll rename this to rating LR. And I'm going to highlight this, and I'm going to do Control-C to copy, Control-V to paste, RFR, and we're going to have our RFR model predict this as well. So we can see what differences there lies there. So let's go ahead and do that. Once again, let's add some comments. And then once that's accomplished, all we have to do is print the predictions. So let's do a print rating LR, and we'll do a print rating RFR. Okay. So this should be good to go. So let's go ahead and click Shift Enter. And here we go. So our linear regression model predicts a score of 8.12, whereas our random forest regressor 7.9, so slightly lower. Let's go ahead and print out the actual value for this. So that would be our test, and we want the target here, and we do ILOC of 0. I believe that is correct. Shift Enter. So pretty good. Our actual value here, 8.07, was the average rating. Let me just do, actually we'll leave this. It says up here, users rated 15,000. So we had 15,000 rate this game, and we were able to come within 0.1, 0.2. Our linear regression model is actually closer on this one. So we're within 0.1 of the actual rating, within 0.05 even. So that's pretty impressive considering 15,000 people reviewed this game, and that's based mainly off the year it was published and the number of users that were playing it and rating it and the total number of weights. So the average weight, very important. Again, that's the complexity of the game. It might be that more complex board games get higher ratings. It's hard to say for sure without doing a more thorough investigation. But in sum, we are able to pretty accurately predict, as you see here, the ratings to board games based off very little information actually. And we were able to train both a random forest regressor and a linear regression model to fit the data of 80,000 board games and predict the average rating from them. So this would be pretty useful if you were a board game manufacturer and wanted to know what types of games people liked and which games got the highest ratings. So this would be a way to use machine learning to accomplish that task. Thanks for following along. I hope you learned a little bit about both Python, Git, using Jupyter notebooks, as well as random forest regressors and linear regression models, and the always important pre-processing of the data. Thank you for listening, and I hope you have a wonderful day.